In this video, we're going to look at the standard equation of a sphere, and you're going to find out that this is going to be very similar to what we looked at with the standard equation of a circle, but now instead of 2 dimensions, we're going to move into 3 dimensions. For example, when we looked at the circle, we said we would have x minus h squared plus y minus k squared, and then we would set that equal to r squared, and if we did that, this would be the equation for a circle where h and k was the center. Well, now that we're looking at 3 dimensions, we're going to add on the x, y, and now the z component, and we would write that as z minus j squared equals r squared. And what we have here now is the standard equation for a sphere, and the center of the sphere would be the h, k, and j. And then once again, the radius would be the square root of this r squared, so the radius would just simply be equal to r. So this here is the formula for the equation of a sphere. For an example, if we had, let's say, x minus 2 squared plus y plus 3 squared plus z minus 1 squared equals 9. And we said, what's going to be the center of the sphere? Well, the center of the sphere would be this h, k, and j. And for this example, the center would simply be 2, -3, and a +1. So remember here, it's x minus 2, but the x minus 2, the minus, if we look at the formula up here, the minus is already there for each one of these. So that means this 2 has to be positive. Just like here, it's a +3, but the minus is there, so really this must have been y minus a -3, which made it y plus 3. So the center is 2, -3, +1. And then, of course, the radius would be the square root of the 9. So the square root of 9, that would simply be 3. So from the center of the sphere out to a point on the sphere would be 3. So that means we're having, the sphere, you can think of having a ball that is centered at 2, -3, 1, and then from that center, we're going to go out a distance of 3 to form the sphere. All right, now, there we were given the equation and we had to identify the center and the radius. Well, now we're going to be given the equation, but it's not going to be in standard form. We're actually going to have to complete the square to write the equation in standard form. Okay, so we're going to have to use complete in the square. So if we have 2x squared plus 2y squared plus 2z squared minus 2x minus 6y minus 4z plus 5 equals 0. Now, this could be very similar to what we did before with our equation of a circle and some other equations we looked at, putting them in standard form in the past, but now we're looking at this for our sphere. So the first step here in putting this again in standard form, and keep in mind our standard form is x minus h squared, y minus k squared, and z minus j squared. So here we want nice perfect square, a binomial that we're going to square here. So we're step is we need to come up with our 3 perfect square trinomials, and to do that we have to complete the square. So the first step is to group our x's together. So we have a 2x squared minus 2x, and then we have the 2y squared and minus 6y. And then we have our 2z squared. And then we have the minus 4z. And we have a plus 5, so I'm going to move that 5 to the other side, and that would become a negative 5. So now, we need to remember or recall, how do we complete the square? Well, that's where we're going to take our b value, divide it by 2, and then we're going to square that amount. And remember, the b value is the coefficient of the x. So in this case, it would be the coefficient of our x, the coefficient of the y, and then the coefficient of our z. Now, the other part is when we go to complete the square, our leading coefficient here of the x squared must be a 1. So here we have a 2x squared, we have a 2y squared, and we also have a 2z squared. So we have to make each one of those a 1 in order to complete the square. So if we think of grouping each of these together, we could factor out the 2 so that our leading coefficient becomes a 1. So if I have 2x squared minus 2x, we can factor the 2 out, and that'll leave us with 1x squared minus x. And now I'm going to leave a little bit of space in order to add in what we're going to do to complete the square. And we can do the same thing here. We want to get rid of this 2, so we need to pull the 2 out. So we pull out a 2. And that would leave us with y squared minus 3y. And again, I'm going to leave a little bit of space to add on our term. And then we need to pull this 2 out, so we would factor out a 2. And you're left with z squared minus 2z. And then all of that's going to be equal to a negative 5. Okay, so now we actually have to complete the square using taking half of this b value and square it. So here, now that we have all of these have a coefficient of 1, our b value here, this is understood to be a negative 1, our b value here is a negative 3, and then our b value here would be a negative 2. So we take half of negative 1, and if we take half of negative 1, that's going to be 1 half, or negative 1 half, and then we square the negative 1 half. If you square negative 1 half, that would be a positive 1/4. Now, what we have to remember is, though, if we add a fourth here, remember we're adding that on the inside of the parentheses. So really, the 2 out front would be multiplied by that to give us 2/4. Well, 2 times a fourth, this is really 2/4, which would be equal to a half. So we really added 1 half. So over here, we're also going to add 1 half to the other side. And then again here we have our 3, or negative 3. We're going to take half of that. So half of a negative 3 would be a negative 3 halves. And if we square a negative 3 halves, that would be a positive 9/4. And once again, we have to multiply that by the 2 outside because it's on the inside of the parentheses. And that would end up giving us 2 times 9/4 would equal to 9 halves. Okay, so that would be 18/4, which reduced to 9 halves. So that means we have to add 9 halves to the other side of the equation. And then once again, we're going to take half of a negative 2. Well, half of a negative 2 is negative 1, and negative 1 squared would be a plus 1. And again, we multiply about the 2 out front, so it means we really added 2, so we have to add 2 to the other side of the equation. So now we have completed the square. So if we go to factor this, we would have a 2, and then x minus x plus a fourth. How does that factor into a perfect square? Well, it's going to actually factor to x minus 1 half squared. And where does the minus 1 half come from? Well, the shortcut for factoring that is, it was simply what we took half of the b value. Right here was a -1, so half of a -1 is a -1/2, and that's how we factor this. So if we look at the next one over here, we take half of a -3, so that means this would be -3/2 squared. And then for the last one here, we would have -2z, so the -2, half of a -2 is a -1, so that's z minus 1 squared. And then over here we have to, on the right side, we have a -5, 1/2, 9/2, and 2. So 1/2 plus 9/2 would be 10/2, which is 5. 5 and -5 is going to cancel, so therefore we're simply left with 2. Now, if we go back up here and look, our standard form is x minus h squared, y minus k squared, z minus j squared equals r squared. So there's nothing multiplied in front of those. So here, we need to get rid of the 2 in front of each one of these. So we could simply get rid of the 2 by dividing by 2, which means we have to divide the other side of the equation by 2 as well. And then we would be left with x minus 1/2 squared plus y minus 3/2 squared plus z minus 1 squared equals, and 2 divided by 2 would be equal to 1. So there's the equation for the sphere. And if we wanted to identify the center now, we know that that would be 1/2, 3/2, and 1. And then, of course, the radius would be equal to the square root of 1, which would be 1. So once again, 1/2, 3/2, and 1 would be the center of the sphere with a radius of 1. So realize this is very similar to what we did with a circle when we were talking about 2 dimensions. And in this case, we're looking at 3 dimensions. So now we have a sphere, but we have x minus h squared, y minus k squared, z minus j squared equals the radius squared.